Graphs, and this is how jet engines work. Most jet-propelled airplanes use a turbofan design. The turbofan can be thought of as a high-tech propeller inside of a duct called a diffuser, driven by a gas generator. The core. The core of a jet engine is a gas generator that creates high-pressure gas to power a turbine. This setup has compressor, combustor, and turbine sections. The compressor. Compressed air makes for a much more powerful combustion reaction relative to engine size. Compression happens in stages that force incoming air into an increasingly narrow chamber. A single compressor stage is comprised of a spinning rotor paired with a ring of stationary stator vanes, which are attached to the core casing. Rotor blades swirl the air as they force it through the compressor. Stator vanes slow this swirling momentum in exchange for increased air pressure. The compressor has 4 low pressure and 10 high pressure stages. The combustor. Air is mixed with fuel and ignited as it passes through the combustor, releasing a jet of super high-powered gas. The design shown here is an annular combustor, meaning ring-shaped. Compressed air enters the inlet nozzles. Each nozzle is coupled with a fuel injector and is designed to swirl the incoming fuel and air for an even mix. A couple of igniter plugs, not unlike the spark plugs found in car engines, ignite this mixture, and the reaction spreads evenly around the ring. Once started, combustion continues as long as air and fuel are supplied. The turbine. Turbines at the rear of the jet engine are powered by exhaust gases exiting the combustor. Much of the turbine power is used to turn the fan, while a smaller percentage powers the compressor stages. Turbine fins get extremely hot. Some air from the compressor is diverted for cooling, and special coatings are used to keep temperatures down. The exhaust cone is specially shaped to mix and accelerate exhaust streams. It also covers sensitive internal engine parts. The fan. Early jet engines were turbojets, where all incoming air flows through the core. Most modern winged aircraft engines are turbofans, where only a fraction of air enters the core or gas generator, and the resulting power turns a specially designed fan. Again, the fan can be thought of as a high-tech propeller inside of a duct. Air that does not enter the core is called bypass air. High bypass engines are designed to move large quantities of air at slower cruising speeds, a range of about 310 to 620 miles per hour. The exchange for high efficiency is engine size. High bypass engines can be very large, with massive fans compared to core size. Commercial airliners or military transport aircraft are example applications. Exhaust velocity is a major factor in jet engine noise. High bypass engines surround fast-moving core exhaust with large quantities of slower-moving bypass air for quieter operation.